To meet NOAA's goal of ecosystem-based fisheries management, huge quantities of multidisciplinary data must be efficiently collected over the areas and time periods that are important to the interactions of animals with each other and their environment. In particular, the areas near the sea surface, sea floor, and seashore must be sampled on large time and fine spatial scales. To accomplish this, surveys from large research vessels must be augmented with measurements from other sensor platforms, such as satellites, buoys, small craft, and autonomous underwater vehicles, or AUVs.
I'm David Demer. I'm a research engineer and leader of the Advanced Survey Technologies Group at the Southwest Fisheries Science Center. In pursuit of the data required for ecosystems-based fisheries management, the NOAA Fisheries Working Group on Advanced Sampling Technologies sponsored an autonomous underwater vehicle program. The goals of the AUV program are to use AUVs to improve the accuracy, precision, and efficiency of fisheries surveys in the oceanic boundary areas, areas where traditional survey vessels cannot sample or safely navigate. The principal strategy of the NIMS AUV program is to utilize small, portable, instrumented, autonomous underwater vehicles deployed from or independent of survey vessels.
The NOAA Fisheries AUV program specified the first such AUV and contracted its custom design and construction. The NOAA Fisheries AUV is inexpensive relative to larger AUVs and the cost of collecting equivalent data from a survey vessel. It can be shipped anywhere in the world to conduct or enhance stock assessments of fish in the context of their prey and environment.
Hi, my name is Steve Sessions. I work for the Southwest Fisheries Science Center and the Advanced Survey Technology Group. With the recent miniaturization of sensors and increased battery power densities, these sensor suites can now be integrated into buoys, drifters, and autonomous underwater vehicles. The National Marine Fisheries AUV is a small, portable, heavily instrumented platform that can be deployed from fisheries survey vessels, small craft, or the seashore to augment a variety of marine ecosystem investigations.
While AUVs will not replace research vessels, which are essential for surveying far offshore, a fleet of small instrumented AUVs offer the possibility to economically increase sampling in the coastal ecosystems, supporting many of the fisheries in NOAA Fisheries Management purview. The NOAA Fisheries AUV boasts a sensor suite to concurrently explore biological, physical, chemical, and geological aspects of the oceans, and to explore their interrelationships.
My name is Randy Cutter. I'm a research oceanographer with the Southwest Fisheries Science Center. I've been involved with the development of an autonomous underwater vehicle for fisheries research. This AUV has a 38 kHz split beam echo sounder that's used for mapping fish and zooplankton in the water column, for charting seafloor bathymetry and bottom types, and for measuring sound scattering from individual fish and zooplankton. The AUV is also equipped with a stereo camera system used to confirm acoustically identified targets and bottom types. The AUV has an acoustic Doppler current profiler used for measuring animal velocities and current velocities and assisting the AUV in navigation. The AUV has a conductivity, temperature, and depth sensor used for measuring sound speed and describing the physical oceanographic properties important to the animals being surveyed. This AUV is just over 2 meters in length and 35 centimeters in diameter. It weighs approximately 130 kilograms and can be lifted by 2 people. It has a 150-meter depth rating and can swim at speeds over 5 knots. We communicate with the AUV using Ethernet, either directly plugged in, using a Wi-Fi link, or using a radio modem capable of communicating at distances over 1 nautical mile. This prototype vehicle is undergoing comprehensive testing and refinement by the Advanced Survey Technologies Group at the NOAA Southwest Fisheries Science Center. These efforts will guide future investment in autonomous underwater vehicles for fisheries research and surveys.
In addition to developing the NOAA Fisheries AUV, the Advanced Survey Technologies Group has developed instrumented small craft and buoys to study krill and their environment off the Antarctic Peninsula. The krill in this nearshore area are food for thousands of penguins and seals that breed on land during the austral summer months. Yet these large euphausids have traditionally been unobservable using instrumentation aboard survey vessels. The group has also demonstrated the use of a small AUV to survey this area, in collaboration with researchers from the Southwest Fisheries Science Center's Antarctic Ecosystem Research Division, Stony Brook University, and the Virginia Institute of Marine Science.
Shallow and highly variable bathymetry make the nearshore of Cape Shiref unsuitable for study from large ships. The Advanced Survey Technologies Group employed a small AUV in this area. The AUV was equipped with a side-scan sonar to detect the krill swarms, a color video to document the krill's lengths and natural orientations, and conductivity, temperature, depth, and dissolved oxygen sensors to characterize the krill's environment. The pilot project demonstrated that a small AUV can be successfully employed from a small boat in an extreme environment. The autonomous underwater vehicle trials also provided valuable lessons for the National Marine Fisheries Service's autonomous underwater vehicle program. Particularly, launch and recovery operations were identified as areas for improvement.
At the Southwest Fisheries Science Center, we've developed a new system for the deployment and recovery of small autonomous underwater vehicles. The system is based using a small inflatable boat, with weighted straps replacing the floor and a steel bow replacing the transom. When deployed, the straps are lowered and the AUV swims out of the cradle. Upon recovery, the AUV swims into the cradle, the straps are lifted to secure the AUV, and then both the AUV and cradle can be safely hoisted aboard a large vessel or secured and towed behind a small craft. The inflatable pontoons of the cradle serve to protect the AUV from damage when hoisted aboard a vessel with large freeboard. We're continuing to develop and refine these technologies and others to ensure that the AUV is as versatile and successfully deployable in as many scenarios as possible.
Following the AUV testing and refinement and some pilot projects, the AUV will be used for research at all the fisheries science centers. For example, the AUV will facilitate concurrent acoustical and optical measurements of individual rockfish, pollock, Pacific hake, and Atlantic herring, and should assist in the characterization of fish reactions to traditional versus the new quiet survey vessels. The routine use of AUVs in surveys for ecosystem-based fisheries management will follow. Imagine a fleet of small AUVs fitted with a variety of acoustical, optical, and other sensors continuously surveying the living marine resources and their environments throughout our nation's coastal regions.
Sending on a mission 225 degrees, beginning now.
Fisheries resources must be understood and managed in the context of ecosystems. NOAA Fisheries and its Advanced Sampling Technologies Working Group aim to meet this challenge with development and increased use of instrumented small craft, buoys, satellites, and autonomous underwater vehicles as critical components of our nation's ocean observation system. AUVs should improve the accuracies, precisions, and efficiencies of many routine studies, expand some to more critical time and spatial scales, and make other investigations feasible for the first time.